All right, good afternoon, all. Hope you all have had a great week. Welcome to another live stream. Today, taking a break from artificial intelligence, machine learning, going to do something a little bit different. About a week ago, I discovered this thing called the Advent of Code, which is basically like a challenge, or not really. Well, it is a challenge, but like you get a daily coding challenge for like that anybody could do with any coding language, any hardware, anything. They're simple little challenges. Simple in the fact that like they're not computationally complex, but it takes a little bit of thinking to get your mind around some of these things. I had already done the first three a couple days ago, but because I've been so busy with work and other things, holiday stuff this time of year, I just haven't gotten around to doing like what are we at today? The 10th. Oh wait, okay, so I am way behind. So I thought it'd be fun to catch up on some of these today. Like I said, or let me go ahead and start to share my screen to show like what this is going to look like. Because I want to talk through, I'm going to be doing everything in Python, but I want to talk through the whole thought process. So you don't necessarily have to do everything in Python like I am. You can, like I said, you can do these challenges in Java. I even saw somebody trying to do it in Fortran, so that was kind of interesting. So let me go ahead and pull up Safari. Safari, that's my browser of choice. Advent of Code. All right, so this is the site that I'm referring to. You can see that, like I said, I've only done the first three so far. I did start a tiny bit on the fourth this morning, but that's where we'll pick up today. I personally, with these challenges, or even with all my experimental code that I'm trying to do, I prefer to do everything out of a Jupyter notebook. And so that's what we're going to be working with today. We're going to be doing these coding challenges out of a Jupyter notebook. I feel like I'm missing something. Like I was going to say something, but I don't remember what it was. I do have, so I am streaming simultaneously to both YouTube and LinkedIn Live at the same time, and I am monitoring the chats on both down below right here. So if you have any questions, comments, suggestions, please feel free to drop them in the chat here. And I'm just checking my technology here to make sure everything is working, and it appears it is. Okay, so let's go ahead and jump on into this. Let me first off, let me open up a second window, do a side-by-side deal here to show you all what I'm doing over here. So typically, well, actually, I've done most of these challenges so far just on my iPad. I think I've showed you before. Where is my iPad? Is it even in here? It's right up there. So I prefer, I have the 13-inch iPad Pro. I do have a keyboard with it, and I'll do a split screen side-by-side. I'm smelling this because it smells like Starbucks because I was at Starbucks this morning. And then I'll use on the left side of the screen I'll have Safari open. Let's see if do I still have this open from earlier today? No, it looks like I might have closed that. But anyway, so on my iPad here, I like to have Safari on the left side, which is going to contain the actual coding challenge, and then Juno, which is like the Jupyter Notebook app for iPad, and so it's a really nice experience. So if I was going to do these coding challenges on my computer here, I probably wouldn't share just one screen. I'd probably have one screen up here, one screen down here. But because I've got all my streaming set up on this screen, plus I don't want to have to show two different screens, I've just got the one up here, but no problem. So the nice thing about the Mac though is if you ever go I'm all tongue tied right now. If you would like to go in side by side mode here, you just got to put both your apps in full screen, take one over, drag it on top. Oh my gosh, there we go, and then I can open up the left or the right side as a Jupyter interface. Okay, so you can see here on the right side I got my own side here, and maybe I'll make this a little bit bigger over here, and then maybe I can zoom in here. But so like I said, we are going to do challenge 4, and so I already did start to look at this a little bit, but the first things first. Well, actually, let's make this bigger for now, just to talk through this problem here, or even before that. First things first, when I think through these coding challenges, I try to think of like, how would I do this first if I was not gonna use code or anything. So like the idea with that is, okay, how do you get the principle of what you're trying to do here and then actually trying to translate that to code? Okay, so what this particular challenge is, and so these are all kind of Christmas oriented. So We're jumping into day 4, but if you start on day 1, I don't remember what there's like a storyline that kind of goes through this whole thing. It's not really important, but so like I think the last one was like I had to go in some submarine or something. So that's why it's saying like we're starting off with this thing here. Like you're already almost a quarter of or a kilometer and a half, almost a mile below the surface of the ocean. That you can't see any sunlight, and what you can see, however, is a giant squid that has attached itself to outside of your submarine, and maybe it wants to play bingo, because giant squids, they love themselves some bingo. So yeah, so basically, all right, so what the way these challenges are structured, so there's actually 2 challenges per day. One is like an easier version, and then after you complete the easier version, then you go into the harder version. And so what they do is they provide like an example of like what you need to do, and then like you basically got to use a different set of input data that is a lot larger than this, because this is a pretty small sampling of input data. And yeah, so and it's basically talking about what you need to do here. So basically, like the first line of numbers here is I think like the input, like, so let's imagine like these, I'm calling these the bingo balls. So like somebody's going to draw a 7, we don't have the letters in here, these are all just integer values. And then the arrays of numbers down here, like the thing that I just highlighted here, that counts as like 1 bingo card. Okay, so like I said, I've already started a little bit on this morning, so I know a little bit about this, but I haven't gotten too deep into it yet, and you'll see why here in a minute. Okay, so after the first 5 numbers are drawn, 5, 4, 7, 9, and 11. Oh my gosh, 5, 4, 7, 9, 11. I can't believe I just got those numbers right, but totally read them in the wrong order. That's kind of weird. 5, 4, 7, 9, 11. But all right, so anyway, there are no winners, but the spaces are marked as false. So this might be a little bit hard to tell, but like this number 11 here is a little bit brighter than some of these others, or the 4. And then so after the next numbers, and then so eventually you do get a bingo. So on this top row here, 14, 21, 17, 24, 4, that's a bingo. Now the one thing that was a little bit confusing is that like I don't think it marked in here what a bingo qualifies as. So I am assuming here a bingo qualifies as any horizontal row getting a bingo. So that's obviously validated here. Any vertical, and now the one confusing part, and I'm going to assume that you do need it this way, and I guess we'll find out here in a minute, is if you can do diagonals, or if you have to take account of diagonals. So the big question is obviously in real bingo you can mark some of these things off like with like a stamper. My grandma used to love doing bingo, and she always had like these big old stamper things that you could just like boop 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 like in a big. I've never actually played like legit bingo. Like my daughters like to play this Disney bingo thing, but that's a different thing. But like legit bingo, I have basically no experience with. Oh, drink of the day is diet tea. I'm trying to get away from drinking too much soda. Like I've just been feeling kind of weird, and I know it's because I've been eating like trash. So I'm trying to be a little bit healthier. Let me take a quick sip. Okay, all right, so let's see what happens after the bingo is achieved. So the score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. Okay, in this case the sum is 188. All right, this is going to be perfect because I had what I was thinking to do here to calculate the bingos. And I'm not sure how to do this in code quite yet. So let's talk about like let's lay out some ground rules of what is considered cheating and not cheating. So what is considered cheating here is if and we're just doing this for fun. So I mean, theoretically, there's no consequence for cheating, but that's not the purpose of this. We're not, because at the end here, like what we're trying to do is get the sum of, or like, all right, so then multiply the sum by the number of that was just called when the board one was 24. Okay, so that's the way all these puzzles work. And let me see if I can, unfortunately my little icon there is kind of in the way. Sorry, but basically they give you like there is only one correct answer. Like the correct answer is going to be whatever we type into here. And I don't want to type in a correct answer because I know that like if you type in the first incorrect answer, you have to wait like 30 seconds before you can type in another. And I don't know if you just do too many that they just kick you out. So I'm not going to type anything in here yet. But where was I trying to say with that? Oh, so 0 is a value in here. Poop. Okay, well, I think that should be fine. Because basically what I... Okay, I'm jumping ahead. Because I'm thinking while trying to talk here, which always never goes well. We were talking about laying out ground rules. So ground rules here, we are not going to look at anybody else's code. We're not going to go Googling, because you can just Google admin code day 4 and find the exact answer, or somebody's exact answer. That's the nice thing about these challenges, is they're so flexible. Like, even though we're writing ours in Python, after I did finish day 3, I went and looked at somebody else's day 3 to see what they did. And I mean, conceptually speaking, we did the same thing, but whenever it comes to the syntax of how we wrote it, it was totally different. So that was interesting. So that I would consider cheating. Now, what is not cheating? What is not cheating, I would say, is, like, let's say we're trying to figure out how to do something conceptually that we've not done before, like, generally speaking. So, like, and I'll just give a little bit of a spoiler here. I've never worked with NumPy matrices before, and I have a feeling that a NumPy matrix would be really good help here. So what is not cheating would be, we're going to be Googling how to do like matrix operations with NumPy. And then, so, like, looking at Stack Overflow, I do, or just like the official documentation of NumPy, I do not consider cheating. Because, that's the other nice thing about this coding challenge. And the reason that I'm doing it is because it's helping me to consider things that I'd never considered before. And in fact, like, with the one of the challenges, I have already applied that to my daily job. Like, was something I learned from day 1, 2, or 3. I don't remember which day. It was minute, of course, but it was something that I went ahead and applied this week in some capacity. So that was kind of cool. And so that's why I want to keep doing these challenges, is because maybe it'll spur on some new ideas of how we can consider things going forward. Okay, so, all right, let's bring this on over, and let me just show you what I've done already. Okay, I forgot to show the input in case you're not familiar with this, so you can't really see that well, but let me open this in a new tab. So what this over here is the input data that we have to work with. So you can see that the sample is pretty small. The sample is just, a couple numbers and then basically 3 boards here. And then when you look at the actual full thing, like, there's quite a bit here. So what I've already done is, let me go ahead and make this a little bit smaller, and I'm going into admin code. And so, by the way, this is all on GitHub if you want to follow along with me directly. So if you go to github.com/dkhundley, then you go into my repositories, and you go into admin code. I've got day 1, 2, and 3 up in here. I don't have my day 4 work in here quite yet. But yeah, so that's where I'm at right now. So let's get into day 4. You can see that I have downloaded this same input data here over into here as AOC day 4. AOC standing for admin code, not the admin code, and then day4.txt. So let's go ahead and open up this Jupyter notebook here, and I'm going to go ahead and clear the outputs, restart and clear all outputs. And so, part of the reason I like, this is going to be a challenge since my big old head's right there. Maybe, okay, I got an idea. Let's flip-flop these. All right, so let me escape this here. All right, I'm going to make this big again, and then we're going to move this to the left side of the screen. How about that? That might make things a little bit easier. Perfect. Yes, that's exactly what I wanted. And, that's right in half, but let's make that a little bit smaller. So, sorry, my big head's right in the way. Okay, so what I've done so far, and this is another reason I like to use a Jupyter Notebook, is because you can then annotate your code with, like, plain text markdown files. So you can see here that I've just got a simple header, and then, I don't know, usually I like to put a longer description, but I've gotten a little bit lazy, so I've just been putting stupid jokes in here, like, or little rhymes, like, what's that knocking at that door? It's admin of code, day 4, and then the link here goes off to links off to this page. And so, by the way, if you're not sure how to do a link in Markdown, it's actually really easy. You just basically have to put the text that you want to hyperlink in brackets, followed by a parentheses with the actual URL in the middle there. So, like, let's say I'll do Google, like Google's website here. So I'll just put Google in brackets, and then in the parentheses here, I will put www.google.com. And then when I enter that, now we have this nice little hypertext link here, and it's actually clickable. So if I clicked here, you're requesting a page that does not exist. I don't know why that didn't work. Does this not work either? Okay, that worked. Maybe it's just because I didn't have the HTTPS in front of it. HTTPS://. All right, so let's try that again. All right, Google. Okay, that time it worked. All right, so let me go ahead and delete that. All right, so what I've done here, and this is what I've been doing with all the files so far, is it seems like, I don't know if this is going to change in the future with the other efforts that we're going to be, or coding challenges we're going to look at. They've all been these text files, like nothing's been fancier than this. This one's a little bit different though, because usually the inputs are uniform, meaning like, let me pull up a different example. So where's day 3? I just did day 3. So day 3's input's just a bunch of binary values. And so let me look at the input. So nothing special about these. The only day 4 is a little bit different because, you know, this looks like it's multi-line, but this is actually just one line. It just is wrapping because my screen is small. And so what I did here is, you know, we're doing the standard with opening the text file as a file name. Then we can do, I'm getting the first line, which I'm recording as the bingo ball, so doing an f.readline. So readline will just, what that does is it extracts the first line as a string out from your text file there, just one line. And then if you were to run that command again, it would just keep getting the next one and the next one and the next one. So that's why when I do the bingo boards here, I'm getting everything else. So, so I did that. And then the next thing I did was, well, actually, let me go ahead and run this just to show you what it kind of looks like before I did any alterations. All right, so let's look at bingo balls. Bingo balls. Okay, so as you can see, and this might be hard to tell, but with the quote, the quotation mark here, and maybe, you know what, I'm gonna go ahead and move this off to a different screen for now, and if we need it, we'll bring back the side by side later. Okay. So what I did, this is just like one big old long string of values here. And so what I wanted to get these into is where there are a list of numbers, integer values specifically, and they're like their own entry. And so that's what this code here is doing. Is this looks really messy, but it's just a joining of a couple of different things. So let's walk through this one by one here. So first things first is I want to get rid of the new line character. So this is a new line character here. Easy way to do that is just doing a replace. And so we're basically saying, okay, replace the new line character with nothing. I could have put anything in here. You can put any value you want in there, but because I didn't want that in here, I wanted nothing. And then the next thing we did, so after that is run, then we do the split. And so what the split does is saying, okay, every time there's a comma, basically split the number here into its own string. So this is still a string value. In fact, let me just go ahead and show this real quick. Replace, so that way you know that, like, because I want you all to understand the concept of what we're doing here. Okay, so just running the replace, you can see that it just got rid of the new line character at the end there. Okay, and actually let me go ahead and let's keep this up. I want to keep up the raw one just so you can see the transformations along the way. So, okay, we got rid of the new line character. Good. So that's the first thing. Next thing up, we're going to do the split. Split is going to, and we're splitting on the comma here. So what this is doing is you can see, okay, we now have a list of all of these values here, but because you can kind of tell by the string there, like the quotations here, sorry, that these are still integer values here. Or I'm sorry, not integer values, they're string values. So we need to convert those to string values. Or, wow, I'm getting backwards all over the place. So we need to convert these to integer values. And so the way you do that is by using this map command. So the map command is saying, okay, the first entry here, is we want it to all these things to be of type int. So we're passing in basically that, and then I'm going to wrap these in parentheses just to make it really clear. Like, okay, this is just, we want this to be its own kind of entity first. All right, so it's going to be map, and then we can't just, like, I think if I just ran the map, that it would just show a map generator. So that's why we then need to transform it one more time into a list. All right, so list map thing here, and then at this point we are, I want to make sure, because 1, 2, 3, 4 parens. Okay. Uh-oh, what did I mess up here? Oh, duh. Okay. All right, there we go. All right, there we go. All right, so after running all this code, this is basically the output. So we have now a full list of integer values here, which represent our bingo balls here. And so I'm going to go ahead and cut this out because I don't need it anymore. But that's basically what this was doing here. Boom. Bingo balls are now the way they look. And I'm going to cut this out here. All right, so next things up is we need to basically do the same transformation for the bingo boards. And now this one's going to be a little bit different in that, we just had basically one line of text before. So let's actually look at it. I'm going to add a new cell here. Before, we're just going to look at the output of this line here, just the bingo boards. Bingo boards. So you can see here, this is just an array of a ton of, like, all these are representing a different line here of the text file that we were in. So again, if you see the \n right there, that is a Unicode representation of just saying, okay, I want a new line in the text. So if you look over here, this is our raw data. So even though you don't see anything in here between like with this 9 and the 68 here, where it's just like this blank space, that is in Unicode, that is a new line character. And so you can, let's go back to here, so you can see, because we already read in the bingo balls, then we have like the new line characters here. And so that was basically what I was doing here. The only difference is, so this is the same code that we saw up here. We just need to do this for every single line in here. And so I just did a single line iteration here saying, okay, for X in bingo cards, bingo boards, for X in bingo boards, so basically it's for all these lines in here, basically do this same operation. And so after we do this, here, let's go ahead and cut this out because we're good with seeing that for now. Let's look at bingo boards again. Bingo boards. Okay, so you can see now we have a list of lists, and you can see that they all represent all these different bingo boards here. And so that was the next thing I did is, we still have these new line, these empty arrays that represented the new line characters. So that's where I got to this point. All right, so cut that out. And so we're basically doing list iteration again here. So for X in bingo boards, I'm going to clean this up a little bit. So, because, a lot of people like to do for I, for X. Just to be perfectly clear, I'm going to change this to saying for board in bingo boards. So board.replace, and then I'm going to put, so for board in boards, bingo boards, if board is not equal to empty. Okay, so let's go ahead and restart this whole thing. All right, so let's run these first couple cells. And that is basically where I've gotten to so far with this challenge. Now is where things get a little bit interesting. So the next thing that we need to do is, and this is where I was just starting to experiment with some things, is trying to figure out like how to best iterate through all of these boards each time a bingo ball is drawn. And so that's where I thought it would be interesting to use NumPy matrices. So if you're not familiar with NumPy, NumPy is a Python package that we use in the data science world for a lot of like array or matrix operations, because basically behind the scenes, like the way it was written is it's written directly against C code. And basically it's a lot more efficient than trying to like do other kinds of code. And so we can do a lot of very powerful operations with NumPy as opposed to just using like standard Python out of the box. And so that's where I was trying to see like, okay, I knew you could do a matrix, but I didn't know like how this is going to work out. So I was just doing some testing here. And so this is, again, not trying to get to the end solution right away. The first thing you want to figure out is, okay, these small little chunks of how do these things code on a smaller scale, and then what am I trying to say here? Like, how do these things code on a smaller scale? So then whenever we get to the end code, then you could start putting all the puzzle pieces together to make our final solution, basically. Okay, so that's what I was doing here, and I was just looking at so I basically took from the bingo boards the first 5 here. Is that the first 5 here? That's another reason I really like using Jupyter Notebooks, is if I want to just check to see like what is what is this bingo boards thing. So if I do 0 to 5, like what's that going to print out? So yeah, okay, so 0, 1, 2, 3, 4. So that's the thing I need, that it's kind of hard to wrap your mind around, because you're wondering, okay, you say 0 to 5, wouldn't you expect 6 entries? No, it goes 0 up until like the start of 0 up until the start of 5, sorry. And so like you actually are not getting the 5th array entry. You're getting up to 4, like you're stopping at 5, but you're not getting that 5th one, if that makes any sense. So that's why we see 0, 1, 2, 3, 4. And then even though it says 5, we've stopped at 5. So this is basically our first bingo board here. And so that was, well, I got to check to see the inputs here again. Okay, are there zeros in here? Yes, there are 0 values. Dang it, that's not good. And the reason that's not good is just because my thought is, okay, let's say like 83 comes up. Then my thought was, okay, if 83, then any value that is 83 in here, then send a 0. And the reason for that is then we could, at the end of this, whenever you have your winning bingo card, remember, like, you're basically supposed to take that winning bingo card, and then for any remaining values, you're supposed to add them up and then multiply them times whatever that last bingo ball was. And so I was saying, okay, if it gets marked off, then just give it a 0. But that's not going to work if we have zeros as entries here. So let's think of a different solution. And the reason I liked 0 as a solution as opposed to like an X is it would still keep it as a number. And that's where I was just trying to make sure that, like, yeah, okay. All right. So first thing, I'm just trying to figure out like how you kind of use these NumPy matrix operations to actually do things. So you can see I already started to do a little bit here. So I did board 1 equals NumPy bingo boards here. And so the one thing I was trying to figure out is, okay, I know that there's a diagonal function. Now what about if I want to, here, I need to take another drink here. Like, what about if I wanted to do the opposite diagonal? So you can see here, in this case, a diagonal would be 68, 56, 21, 97, 39. And so let me just show board 1 dot diag. Is it dot diag? Oh, whoops. Matrix operation has no. Okay, so I have to Google this because I don't. And again, I do not consider this cheating. Matrix, NumPy, matrix, diag. Okay, so it's numpy.diag, and then what? You just pass in what the matrix that you need. Okay, so this should work. All right, so let's do np, because that's how we've aliased it. That is a very common alias for NumPy, is import NumPy as np. So np.diag, board 1, and let's see what. Well, okay, let's keep this up. Board 1. Let's keep it up just so we know what it looks like. All right, so np.diag board 1. Okay, so we see here 68, 56, 21, 97, 39. Perfect. All right, and then I already figured this out because I wanted to see how do you do a reverse diag. I had to Google this before earlier too. So you have to do numpy.flip-l. I don't know what flip-lr though. Yeah, let's look up what that is. NumPy flip-lr. Flip-lr. Okay, reverses the order of the elements along the axis left to right. Okay, so I like to look at some of these examples. So it looks like you have a diagonal. All right, it looks like these are zeros, and then, okay, so the diagonal of these zeros array would be 1, 2, 3, and then when you flip them, it goes backwards. Okay, so, and this code does work. So if I just do an numpy.flip array, then you can see we have the reverse diagonal. 49, 64, 21, 5, 60. Okay, so that, and the reason that's important is because basically we're going to like use these operations to kind of figure out, oh, all right, so I'm trying to think of a new way around it because I was just going to put everything as zeros. And so I was basically going to say, okay, if numpy.diag equals 0, then you got a bingo. Or everything is 0, then you got to have a bingo. We're not going to be able to do that, obviously. But let's pretend that is the case. Well, I'm just trying to think out loud again. So 68, 56, 21, 97, 39. I wonder if equals 0. I'm just curious. Equals 0. I'm just curious what's going to happen. Okay, so those are all false. Dot. All right, so those are all false. So this is good because this is going to be able to tell me, all right, if I do an X here, then if all of those are true, then a bingo. All right, so how do I get to see if all those are true or false? All right, so if all false, dot. Is there a way to do a dot sum? Dot sum. All right, dot sum is 281. I shouldn't have deleted that. All right, so, well, let's just do it down here. So 68 plus 56 plus 21 plus 97 plus 39 equals 281. Okay, so that's interesting. But what if, all right, so, because now actually changing the value is going to be pretty easy. So, well, I guess that's a good thing. Good thing I've asked because I don't know that it's actually going to be easy. So let me just see if I can understand how the matrix operations work. So if I want to get value 68 out of here, my thought is that you would need. Well, let me just show, because like when you do brackets like this is basically referencing like an X value of, okay, I want like this first array. So the like 0th array should be 68, 73, 98, 51, 49. So let's go ahead and run this, and that's what we should see. Okay, perfect. All right, so now if I just wanted 68 then, or no, let's actually make it a little bit more challenging. I want 73, and this is not really more challenging. So in this position, in this array here of this matrix, the value 73 is going to be the first position. So then we can do that. 1. Okay, so that doesn't work. Good to know. Huh. All right, so let me see how we can get a value out of a 2D array. NumPy get value from matrix, from 2D matrix. All right, so how do you access the elements of a 2D matrix? Okay, so let's say I have all these things, then 1, 1. Well, that's not what I wanted to see. That's not a matrix. That's just a 2D array. All right, accessing data along multiple dimensions in array. Okay, but these are arrays. I want matrix. Get me the matrix. Oh, speaking of matrix, if you all follow me on Instagram, I just looked at the tech demo. There was a tech demo of Unreal Engine 5 supporting the Matrix on PlayStation 5 and Xbox Series X. And it's free, and it was just launched last night, and I just tested it out. Very interesting, very cool. It's not perfect, but very interesting to see how graphics in video games have come along. All right, so let's keep going here. All right, so NumPy.get value from, well, let's just do a matrix. I don't know if you all can hear that. My daughters are playing right above my head, and I don't know what they're doing. Their playroom is right above my head. Okay, so NumPy.matrix.item. All right, so matrix.item, copy an element of it to its. Okay, so this is the item 7 is 0. Okay. Well, okay, now I'm curious, because there's only 5 elements in here, right? 5, 4. Okay, so how do I change? Here, change. All right, so NumPy change element in matrix. All right, how do you change a single value in a NumPy array? This is not helpful, guys. Oh, I wonder if I have to do the comma thing there. I saw a comma thing there. Okay, so let's try that out. All right, so board 0, comma 2. Okay, so that's how you do it. Okay, so to actually get that then, all right. So that is saying that. So let's go ahead and change this value to, let's just make it really big to make it really obvious. 80, 80, 80, 80. All right, so I think that's how you would change it. So let's look at this again. Okay, so perfect. That's exactly what happened here. So you can see here, I said Board 1 here, I want this value to be 80, 80, 80, 80. And it is. So now I'm just trying to figure out like what is the best way to iterate through a matrix to check all of its values. Okay. And let's go ahead and restore this back to what it was. So restoring that back to what it was. All right, so for I, all right, so let's see if there's because usually these NumPy like things have a better way to iterate through. NumPy matrix iteration. All right, NumPy. All right, now why did I keep wanting me to look at like the rows? Oh, all right, so you can use NumPy along axis. Apply along axis, my function, axis 1, my matrix. All right, so what does this person want to do? I want to be able to iterate over a matrix to apply a function to each row. How can I do it for a NumPy matrix? Apply along axis. That, well, what is this person doing here? So, okay, it's just the sum of the values, right? Okay, so apply along axis. Well, let's try this out. So for I in board 1, print I. So what's I going to print out? Okay, so it's basically just printing that. So let's see for I in there, for X in I, print X. Not very helpful. Okay. I0, maybe? I0. Not helpful. All right. Gotta think through this. Okay. All right. Well, let's try it and see if we can figure something out again. Apparently, not a whole lot of people do stuff with matrices here. All right. So single array iteration, controlling iteration order. So for x dot in np dot nd iter, well, I want to know how to iterate a matrix iteration. How to iterate over a 2D matrix. 2D matrix? Sometimes like that's the challenge about coding, is just knowing like what is the proper thing to what's the proper thing to what's the word I'm trying to look for? Google. Because I'm just trying to think through, like that's the biggest challenge of thinking through as a problem right now, is I'd probably be going a lot faster if I didn't try talking the whole time. But I just feel bad. All right, how to loop through 2D NumPy array using X and Y coordinates. Okay, so that is, all right. So for I and nd dot index dot a dot shape. Oh, this is interesting. All right, now you get prettier code with that. So I'm just going to copy this here, but this is not going to really help me anything. All right, so for ix in numpy.a.shape, board 1 dot shape, board dot shape. And actually, let's go ahead and do that. Let's see what does board 1 dot shape do. Board 1 dot shape is saying, okay, this is a 5 by 5 matrix. Okay, so board 1. Okay, so we're getting somewhere. All right, so for ix, iy, all right. Because sometimes I just want to print out like what do these things actually mean. So I'm going to do a string here. I'm going to say iy equal, I forget what these things are called, iy. And then I'm going to do the same thing again here. So print f ix. So I just want to see what are these things doing? What are these things producing for us? Okay, so it is saying, all right. So it's basically going through each element in the array. Okay, this is perfect. This is perfect because it's basically saying for every element in the array here, we're gonna check to see like what this value is here. So it's basically going left to right, kind of reading like a book. So you see, 0068, 0073, 01 is 73, 02 is 98. This is perfect. All right, this is exactly what I needed. So so the y value is, I don't know why this guy called it iy, because this is really the x value. The x value, all right, so I'm going to call this for x comma y in np.nd index. wonder what ND index. Let's look up what this does because I like to, one thing. It's one thing to just copy the code and see like, okay, it works, done. All right, but I like to understand like what is this little guy doing here? What is ND index? So NumPy ND index. NumPy ND index is what? All right, an n-dimensional iterator object to index arrays. Given the shape of an array. Okay, so it's basically saying, because we got a 5 by 5 matrix here, it is not actually, the way I understand it is not actually looking at the values of here. It's just basically saying, okay, you have a 5 by 5 matrix. It's more or less treating it like, okay, I know what the index values of all these things are. I don't know what the actual values are. And that's okay. That's perfect for us. And I know that probably doesn't make any sense to you of how I explained it. And so you might be wondering, okay, why are we just doing things on one bingo card? Is because we're trying to figure out how things work with one bingo board, and then we keep adding everything together. We're just peeling back. We're kind of doing a reverse of peeling back of the layers of the onion. We're starting at each slice of the onion and putting the onion back together. Terrible analogy. So awful. I wonder if people are even watching this. I actually don't monitor to see like who's watching or not. I see that my wife posted something in the YouTube chat, but that's very nice of her. She's just making sure that my technology is working, which her smiley face I'm taking as my technology is working. Because one time I did one of these streams, I got 40 minutes in and didn't realize that my microphone wasn't working. But I'm getting better. I'm getting smarter. By the way, if you all see on the back of my chair here, I got my Christmas hat. That's because I was wearing it. But like I joke about me having a big head, but I literally have a big head. Like most hats don't fit me. This Santa hat doesn't really fit me. It's kind of funny. My 3 and 4-year-old daughters, they're so lovely, but they have big heads too. And so actually this adult size Santa hat behind me fits them just fine. And they're 3 and 4. So, yeah, big head problems. All right. I don't need this anymore. So let's just do a little demo because let's say our bingo ball. We don't need this anymore. Bingo ball equals 68. No, not 68. Let's pick a number random. It's got to be one of these in the matrix here though. 97. So 97, what is that position is that? So 0, 1, 2, 3, or 0, 1, 2, 3, and then position number 0, 1, 2, 3. Did I really just do a 3, 3? Oh, I guess that would make sense. All right, so let's just verify that for sure. So board 1 equal, or what is that? So I said 3, 3. 3, 3. And yep, that is number 97. So what I'm going to do here is print out. All right, so I'm going to iterate through this board. So I'm going to keep that iteration, and then I'm going to do an if statement. So here, so if, wait, what did I do here? Okay, because I want to get the values. That's right. All right, so print board 1 x dot y. Okay, that's still right. So what I'm going to do here is if board 1 x comma y equals bingo ball, I'm going to print, regardless, I'm going to print the value. Well, no, I'm going to print the value up here. All right. What I'm going to call this? So print f bingo entry is board 1 x comma y. So basically what this is saying is as we iterate through this whole board, I want to see what the values look like. So if this equals the bingo ball, print, we have a match. And then if not, we're just going to skip over it. Now, I guess we don't really need to put an else statement, but for now I'm just going to say not a match. Not a match. All right. So if this works, so you can see not a match, not a match, not a match. Boom, 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 boom. Down to 97. We have a match. All right, perfect. So what we're going to do here is we're going to assign it a different value. Now here's the tricky part is what value do we assign it? Because like we talked about before, we can't assign it 0 because 0 apparently is an entry, and the only problem with assigning it a letter is then you can't do like this what do you call this comparison operator here, because then you'd be comparing a string to something else, a string to an integer. Sorry. Need another drink here. But I hope you can see how we're going to basically be piecing all these things together. Is at the end of this whole thing, we're basically going to be checking to see, is there a bingo? And, it seems like this is going to be, just at a surface level, it seems like this is going to be really complex. Like, this is actually not computationally complex at all. Like, this is going to be a piece of cake. For the computer to do, I should say. For a human to do, this would be kind of a pain in the neck. It's still possible. So actually, this of all the puzzles that we've done so far, this is the one that I think you could actually do by hand and get the answer pretty easily. I mean, it would be time consuming, but my grandma would have had a blast with this. Rest in peace, Grandma. Hope you're doing well. Okay. But then we're going to start piecing all these things together. All right, so if board equals, then we are going to say, let's just give it a value of x, because, I mean, the reason I don't want to give it an x is I'm trying to figure out, like, how do we make sure that this is an actual bingo? All right, so instead of doing a print, I'm going to say if board equals x, delete all that. So we're basically going to say board 1, x comma y now equals x, and let's see if that works. All right, invalid literal for int with base 10 x. Okay, so apparently you can't do that. So I mean, the other idea we could do, because it honestly does not, well, it does matter. Gosh darn it! Like, why do? I mean, I guess we could do -1s. Can we do -1s? Well, let me do -1s. I'm just curious. Well, let me do -1s. -1. All right, so it just looped through that whole thing, and I still had it printing out here. So let's just look at what the bingo board looks like now. And I don't really want to lose this code here, and so I'm just gonna make a couple new lines. Okay, so what does the board 1 look like now? Board 1 looks like that. All right, because the only thing I'm concerned about, because like, all right, so the -1 is there. The only thing I'm concerned about is if, like, how do we make sure that those -1s are not accounted for okay. I don't know. Just thinking out loud here. All right, so I want to get the 4th value of everything. I'm just thinking again, kind of out loud, of like how we're going to analyze the verticals versus, like, because actually the hardest part here, well, I wonder if there is an operation that'll do it, because like actually finding the diagonals was a lot easier than I thought it was going to be because of these matrix operations. Like, I'm just trying to think, like, how do we get the first value out of all these operations, and maybe there is a way to. All right, so NumPy 2D matrix get column. Can we get just a column of values with some sort of thing? How to access the ith column of an n-dimensional, multi-dimensional array. Oh my gosh. All right, so this person has a test array that looks like this. And then so they're just going to say, okay, so test colon, comma 0. All right. I've seen this before. This in my mind just isn't super intuitive, which is why I always forget what it is. But let's go ahead and try this out. So board 1. Okay, so let's look back at our board here. So that worked. That's how we get all of the values of that matrix. Okay, perfect. So how do I check to see that these are all, well, let's see. Equals equals -1. Equals equals -1. All right. So how do I, because I basically wanted to summarize this. Like, how do I summarize that? Summarizing meaning like, okay, all these are false. Or if one of these is false, then all these are false. Because basically we would have, in order to get a bingo, all these would have to be -1. So false, 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 false. Summarize, or so. Okay, so for, let's check. So for x in blah blah blah, print x, print x. All right. So that's just basically getting the values there. So if x equals -1, print sure. Okay, so that actually worked, maybe. Well, I picked a kind of a bad one. Where's the one with my -1 in it? Board 1. Where are you at, board 1? All right, and so I know this looks messy, but I always go back and clean up this code. So, and this will look very streamlined in the end here. So 0, 1, 2, 3. All right, so let's look at 3. Print sure. Oh, well, that's because I didn't put quotes around. There we go. So sure. All right, so okay. All right, so basically we can say, like, if we iterate through these, if it's not equal to 1, then we can break the loop, because then we don't need to keep going. All right, but if it makes it through, then we have a bingo. And how do we know that we have a bingo? I don't know. All right, so let's go ahead and let's see if we can change one of these arrays to like basically like force a bingo. There's got to be a simple way to do that. So 3 equals, well, yeah, there is an easy way to do that. So board 1, we're going to make this whole column, the whole column equals -1. Okay, so now let's look at board 1 again. All right, so basically we have falsified a bingo here. All right, so falsified that bingo. And so for, all right, I guess I don't need that anymore right now. I know this is really messy, but this is just the way I do things. Like, I'm sure we all have different coding practices or whatnot, and I would like to hear what you guys think. If anybody's watching, feel free to drop any comments or any thoughts below in the chat. I'm monitoring these things, and I haven't seen anything come through, which is fine. All right, so if for x in oh my gosh, board 1, comma x 3, right? Print x -1, -1. Okay. If x equals -1, print it sure is. This is, I know this sounds so silly, but this is like actually how I do. All right, so we made it through. Or if it's not equal to -1, then we break the loop. All right, so I don't think we had to break any loop there. But if it made it through, what do we do? Like, how do we make sure that like it did indeed make it through? And so that's the thing is, like, if you find anything, well, no, I take it back. Son of a gun, because I'm thinking like, well, if you found anything like that is negative, then you just break the loop, then you keep going in general. But that's not true. Okay. So let's think through this together. Because all right, so this one's kind of tough. Like, this is actually, I think, the toughest challenge that I've done so far, in my opinion. The other ones were pretty easy. I flew through those pretty quickly. All right, but we're doing it. Like this is not an undoable challenge. It's just trying to think through the syntax of like how to actually properly do these things. Because basically, I don't know if you're. Let's recap what we're trying to do here. So we're basically saying, okay, we're checking this whole column here to see that. Well, there is a way to cheat this whole thing. And that is, if the sum of these things was -5, then you have a bingo. You know what? I think I might actually just do that. Like, because that's... Now, can I do a sum? Can I do a sum of this? Like, is there a way to do a sum? All right. Can I say sum one more time? Dot sum. You know, this sounds stupid, but I think I'm just gonna do that. Like, cause if like no, there's no way like adding any of these is gonna be -5, like ever. So if all right, so let's just go ahead and do this. Like, all right, so yeah, for I in range of 4. Here, I want to just print. Well, let's do this because I always get screwy with these range things. Print I. Print I. All right, 0, 1, 2, 3. All right, that's right. We need to do 5. All right, and the reason I'm doing this is because I need the to like go through every single one of these things here. For I in range 5, if board 1 I well I just want to print sum, right, F sum of column. So the sum of the column is going to be board 1 colon I. And I know I'm just using the letter I right now, but I like to clean these. I'll clean this up with more like descriptive names later. All right, so board 1 I dot sum. That's right. All right, so let's just do that for now. In fact, we'll not even bother with this yet. Leave that out. All right, so sum of the column. So we see 322. That's probably right. I'm not going to bother to validate these numbers, but they look right to me. And so we have a -5 there. All right, so what we're going to do here is if board 1 colon the index value, or like the column value, dot sum equals -5, then print bingo. All right, so let's see what happens here. Boom. All right, so we have a way. All right, we have our system. This is basically what we're gonna do, I think. So, all right, so that's for columns. Now, what about rows? Sorry, I'm just sitting back and thinking for a minute. Because like I know what to do, but like sometimes like this one's a little more complicated. And there's a lot going on that like my brain kind of just has shut down. So okay, with this diagonal dot sum, all right, does that dot sum work on all these? Oh, this is gonna work perfect. This is gonna be great. All right, so let's see if we can start piecing all this together. So if all right, so that's just iterating through the columns. So let me actually put it. All right, so checking column or vertical columns for any bingos. All right, and then so this is also going to be part of one massive for statement. So because basically, I know what we're going to do. We're going to iterate through all these bingo balls one by one, and we're going to be checking to see if like how these things work out. And so we're about at an hour. We're going to finish up this one challenge, and then we're going to call it a day because I think it's going to take me probably another 30 minutes to figure out the remainder of this stuff. But we are on track. I'm pumped. I hope you all are pumped as well. So for I in range 5, if then well, we're just gonna do a break because we don't need to go any further. So like, let's see, like, does that work? So we just break. Okay, perfect. And I don't really need this anymore. So for I in range 5, if board dot sum equals -5, then we break. Okay, perfect. Yeah, and then we're also gonna do the same thing for columns. All right, do columns work the same way? So board one. Is it that we just do the 1, comma? Okay, so that is how it works. All right, so checking for well, because I don't want to have to go through this again if I don't have to. Yeah, I want to make use of this. Well, or okay, let me rephrase this. So checking vertically or horizontally for any bingos. For any bingos. So, and then I'm going to put another comment here. Checking vertical columns for any bingos. Break. All right, but what do I need to say here? So I do. I just thought of the perfect way to get around this whole thing. Sometimes I have really good ideas, but they're also like, this is kind of a kludgy solution, but it's going to work. All right, so we're going to checking horizontal rows for any bingos. All right, so basically if board one, you know what, I'm going to rename this to board because I do want to reuse this code. So board equals board one. I know that's so lazy of me. I'm sorry. All right, so board. I'm not bored. I hope you're all not bored. This is fascinating to me. All right, so board. All right, if board. All right, so then we need the I. And I actually think I am just going to keep this as I because I'm being lazy. Dot sum equals -5. Then we should be good. All right, so because I'm just trying to think again because we're actually going to need to do 2 iterations. We're going to have to iterate first to get our bingo ball, and then we're going to have to iterate through all the boards to check to like mark off any of the entries. So all right, so checking. All right, so we're going to break again. All right, and then we're going to do the diags, and I wish I would have saved the code. Checking top left to bottom right diagonal for bingo. Okay, and I just want to make sure. All right. So what was that again? So numpy, I think it's np.diag. So np.diag board one. Is that right? Boom. Okay, that is correct. All right, so if board, wait, I just literally deleted it and retyped the same thing. Come on, Dave. Don't call me Dave. All right, so if board dot, or no, I'm sorry. If np dot diag dot board, or not board, sum dot sum, right? Is this going to work? I just want to make sure that this works. This is why Jupyter notebooks are so nice, is because I'm sure I actually have not figured out this thing, how to like, because I know you can do like breakpoints in like an actual, what do you call it? Like an IDE. But I've not really figured out how to do that because I do all my work in Python anyway. I guess if you guys are Java guys or JavaScript guys, like I don't know how if there is something similar to that. And transparently, I don't really. I know Java a little bit. I don't know it well enough, but I don't know if like there's like a Jupyter notebook like version of that. There may be, but Python's my guy because that's what I work with on a daily basis as a machine learning engineer anyway. And so far, this is doing really good. So I think that did work. So if that equals -5. Then we're going to break again. So like the reason I've got a break here, and actually this is not, well, I wonder if this code even works. Yeah, that's what I thought, because this is actually going to be part of a larger for loop, and that's okay. Like this isn't, so this code isn't going to work, but right now, but this is going to be fine. So checking top or bottom left to top right diagonal for bingo. Okay, so we basically did top left to bottom right already, and now we're doing the other one. So basically checking both X's to see if there's any bingos there. If, and that's what this is here for. So if this, then we're going to break. Okay, so this is our code here that is basically checking to see if there's any bingos, which is great.
I found this on the web.
Well, thank you, Siri. Oh my gosh, I hope I didn't delete the code about like actually. Okay, so All right, so we are. All right, so we're doing pretty good. I want to clean this up a little bit though, because this is kind of a mess right now. All right, so bingo ball. All right, so I want to call that board. We can delete this for now. We want to keep that. We can delete these couple here for now. I want to make sure that we don't lose this, so I'm actually gonna make a note in here. I'm gonna make a markdown note. This or checking for bingos. I'm gonna make that. This is my checking for bingos code, and I know this code does not work. Does continue work outside of a for loop? Yeah, no, I didn't think so. That's fine. Okay, so we have the code for checking a bingo. Now, all right, so the one thing that we've not figured out yet is how to actually, because I haven't, like right now, the only thing we have is here is our bingo boards, and let me make a couple more spaces. Bingo boards is just a bunch of these arrays. So I need to group them by like fives. Group. All right. Group list elements. Well, I guess is that gonna screw stuff up? All right, so Python group elements in the list. Well, I guess I know it says by 2 here, but by n elements. All right, so how to group elements in Python. All right, so for, all right, so, well, the brute force answer is sublist for n in range. Oh, okay. All right. I think this is gonna work. So it's basically doing list iteration again. Line. All right. So for board in bingo boards. All right. So that we're basically, this is setting up what we're doing. I know we're gonna be doing some more things here. So for board and bingo boards. All right, what did they do here? No, they did a range here. I'm sorry. I messed that up. My bad. All right, so, all right. Okay. All right, so I'm going to copy this. And you know, I'm not cheating here because I'm just trying to see conceptually like what this guy did, and it helps to me to do like a side by side here. All right, so he's doing for n in range from 0 to length, and then the n. All right, so what does the big N stand for here? Okay, so that's just the grouping. Because what I'm trying to figure out here is what is the range function necessarily doing here? All right, so what is range? All right, let's just do range of 0 to the length of the bingo boards list. Bingo boards. Okay, so 0 to 500, so it looks like there's 500 lines there, which I guess makes sense. So there should be 100, and then we need 5, so n is going to be 5 in this case. So range 0 to 5, n. So, well, let's see, let's just print out, like, what does I equal here? For I in range 0, blah, 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 print I. Okay, so we're counting by 5s here. This is great. All right, so I'm understanding this a little bit better. All right, so, all right, I'm going to take this out for board or for n in range. So n plus n. For board in range 0, length of the bingo boards. And then 5. I'm just going to hard code this value because it doesn't really matter if it's hard coded. And then so what we're doing is we're going to append a new entry. So bingo boards. Well, I'm going to call this line. So bingo boards. And then so we're doing the line and then line plus 5. All right, so if this code works, then we should have our bingo boards here, basically. Invalid syntax for, dang it, for line in. All right, where did I screw up here? Is it because I tried having these things together? Here, let's just comment this out instead of deleting it. Invalid syntax again. Okay. List for line in range. Well, let's just see what happens if we just do line. Okay, it really doesn't like my syntax here. I don't know what I screwed up here. So for line in range, 0 big words. Just checking the time here. Bingo boards line, the list, sublist, equals. Oh, yeah. I didn't need that at the beginning there. I'm stupid. Okay, perfect. Okay, so let's just check. What is the 0th value here? Yeah. Okay, we're on a roll, people. We are on a roll. All right, so we're gonna call this segmenting the bingo boards appropriately. All right, so what this is going to do, we're going to call this bingo boards again because we don't really need the original value. Bingo boards equals bingo boards. And so we have our bingo boards now. Bingo boards. All right, people, we're getting somewhere finally. All right, so now we actually want to iterate through our bingo balls, and each time we have a bingo ball, we're going to change that value to -1 in the board. So, drawing a new bingo ball. So for ball, or bingo ball, not bing ball, bing ball. If you've, what is that movie? What is the movie I'm thinking of? Inside Out. There's like the toy that got left behind. His name was Bing Bong, and I don't. Why the heck do I remember those things? For bingo ball and bingo balls. Balls. All right, so let's just print out the bingo ball, just to make sure. Okay, so is that right? I don't even remember what the bingo balls looked like. Bingo balls. Oh, that's because I already did this once. My bad. Let's just do this here. Bingo balls. Bingo balls. Okay, so that's right. Let's see. 83, 69, 34. Is that right? 83, 69, 34. Perfect. All right. So let's cut this out. And I've, every once in a while, because the nice thing about Jupyter is you could see how many times the cell's been run, but like, that's the one bad part about Jupyter is if you jump around too much, then you can actually accidentally mess with crap. And so every once in a while, I like to go ahead and just do a restart and clear all output because it does not matter that, this stuff down here doesn't really matter to keep. All right, so let's go ahead and run these first couple cells again. All right, so for bingo ball and bingo balls, and all right, so the first thing we want to do is we need to iterate through all the boards. All right, so checking for, marking off spot. What do you call the entries? Like marking off number on each bingo board. All right, so for board in bingo boards. All right, so I don't even, shoot. Okay, so we got a lot of for loops going on here, and I hope this is not computationally complex. All right, marking. All right, so yeah. Okay, so for board bingo boards for x comma y in np, oh my gosh, x comma y in np dot n index board dot shape. Let's just, just for now, I want to see if this is going to work. All right, so list object has no attribute shape. All right. All right. Oh, that's because we didn't transform it into a matrix yet. That would be why. For board and bingo boards, And what did I do here? So let's just print out the board. Print board. All right, so how do I change this into a matrix? So np.matrix. Transforming board into matrix. And maybe that's something that I should do. Yeah, I should probably do that. I should. So we're not actually good to go. Let's change all these bingo boards to matrices. All right, so for changing bingo boards into matrices. All right, so for board and bingo boards, print board. All right, I just want to look at, okay, so that's fine. All right, so how do we do the NumPy transformation? Again, board. Oh. Ooh. Because we want to, because this is the one bad thing about iterating through lists like this is you can't actually change, like, you can't iterate through a matrix and change it. I'm sorry, you can't iterate through an array and change it at the same time. It just does not like to do that. So, well, let's just check. What is the length of bingo boards right now? It should be 100, right? Length of bingo boards is 100. Perfect. Okay. So for I in length 100, print I. Oh, wait, no. Well, we do want to do the length of bingo boards. For I in range. All right. Every time we get a little bit closer. All right. So for I in length of bingo boards. All right. So that is, all right. I just want to make sure. So print bingo boards. I. All right. Okay. So all right. So this is gonna work out. Okay. So what we need to do, and I keep forgetting this. Like so, np.matrix. All right. So for I in there, I'm gonna paste that here. So bingo boards. I. Will that work? Let's check. I don't know if that even worked. All right, let's just do test. Equals test, and let's just print out what does the test look like. Print. Well, I guess I could have done that without. Sorry, print. Right. Okay, so that looks right, I think. Let's just do a type. Type. Okay, so that is working. Perfect. All right, so we are, but then we need to set the board to equal that. So bingo boards, I equals numpy dot matrix I. Okay. Fingers crossed this works. Okay. Bingo boards. All right. All right. So for board and bingo boards. And this is just a, well, what is this? Is this still a list or a type? Let's just make sure that the type is still okay. Bingo boards. Okay, so this is still a list. So I don't need to transform these into matrices anymore because I've already done that here. All right, so let's get, I hope I didn't delete this code. Oh my gosh. For X, all right, so to board.shape. Print. I didn't delete that, did I? Okay, I did not. Board.shape. Well, okay, I just want to make sure all this is working. So print board.shape. Okay, perfect. All right, so still good. Still doing okay. All right, I know I've got a type there, but it's hard to hold all this stuff in your head. It just is, and especially when you're trying to type it off on a live stream like this. All right, so x.y and board.shape. If board x comma y equals the bingo ball, and I don't need this anymore. All right. Iterating through all bingo boards to mark off number on each bingo card. All right, so that's the first thing we're going to do is we're going to do the marking off, and then we're going to have to iterate back through it again to check to see if there's any. Well, I guess we can't. No, we can't. No, let's just we can do it in one shot, can't we? Right? Like after we do the card, the marking, then we can go ahead and mark them off. All right, so iterating through all the bingo cards. All right, so marking the numbers appropriately. Marking the bingo card, bingo board if bingo ball is shown, pulled. I'm gonna call pulled. I don't know. All right, so for x comma y. All right, so if board equals bingo ball, then board x comma y equals -1. All right, so that is basically going to. All right, so far this is all the code that we need for the actual bingo, like actually marking off the bingo boards. All right, so now the next thing is we basically need to do the check here. All right, so we are checking to see if anybody's got a bingo. All right, so checking for, dang it, I hate when it does this. All right, so checking horizontal or vertically for any bingos. All right, so if there is a bingo, so break, I want to be able to make sure that the winning card is saved somehow. All right, so for okay, I'm gonna comment all this out for a minute because I want to be able to make sure. So for board, print board. Okay, and so you can see it didn't take that long. Like I know this seems like it's really complex, but it's not. All right. So for board and bingo boards, we're just printing out the board. But how do I get the actual value of that board? Or save the board, I should say. All right, so save the board. How do I save the board? Or what should I save it to? Winning board equals board. Last board equals board. All right, I just want to see what happens if I, like after this. So last board, did that save it? Okay, perfect. All right, I know what to do now. Okay, all right, so before we do the break, we are gonna save latest ball equals bingo ball. And we're gonna say winning board equals board. Okay, and so basically we need to do this everywhere here. All right, so all right, and just to make sure, because I did run this through already here, so let's go ahead and restart the whole thing again because we don't want to muck up our results in any capacity. All right, so running these first couple. All right, so drawing a new bingo ball. Okay, so boom. Board 1 is not defined. Duh, okay. Ugh. All right, let's go ahead and run all these again. Kernel restart and clear output. We're getting close. We're getting close, folks. We are getting close. All right, so last board, or winning board. Uh-oh. Something went wrong. Why did it do that? For bingo board. I don't know what happened here. What happened here, guys? All right, so let's check out our bingo boards. So it didn't change. It didn't change the values of anything in here. Something went wrong. Something went wrong. All right, so for XY and np.board shape, if board XY equals bingo ball, then -1. Like, how do I make sure that, like, just this is working in general? Okay, let's do a smaller sampling. I just want to do a smaller sampling of bingo balls. So, minor balls, or short balls. Sample balls equals bingo balls. 0 to 5. Okay, so that should be sample balls. All right, so that's just going to pull the first 5 balls. So for bingo balls and sample balls, and I'm probably going to have to restart and clear this. Restart the kernel again. Clear all output. Kernel, restart and clear all output. I'm determined to finish this, but I don't want to stream for much longer. I mean, I'm definitely going to finish it, but you can see, like, we're getting so close to it. Like, practically, like, taste it. Like, well, not literally. That's kind of weird. All right, so for XY in the shape, subboard.shape, if board XY equals bingo ball, then equals -1. All right, so let's just check to see, like, what's going to happen if we run this here. All right, so bingo boards. All right, so do we see any negative? So there's a couple negative ones in here. So something is good here. It's just that something bad happened whenever I tried to do this all in one thing. Okay, so I wonder, I'm just out of sheer curiosity, what would happen if I uncommented all of this? And then, because I wonder if it's just being screwy because I tried to keep it all as one for loop. All right, so iterating through all bingo boards to check if any bingos. Okay. For board and bingo boards. Okay. Winning board. I don't see a winner in here. Like, there's no bingos in here, guys. All right, so winning board equals board. Like, how did it get? Oh, well, if in range equals -5, lat equals -5. Well, none of these equal -5. So where did it get this winning board from? I wonder if I just need to, like, restart this whole thing again, basically. Because basically there should be no winning board. Like, there should be no winning board out of here. But something slipped past here, and I don't know what did. What is the latest ball? Latest ball. Like, there basically should not have been a winner. So the latest ball was 30. And what is the okay, so this isn't helpful, guys. Not helpful, guys. All right, so for break. Break. I don't know. Does anybody see what I did wrong here? I don't know what I did here wrong, and I'm kind of like, and the reason I'm not talking is just because I'm a little bit bamboozled on what I may have done wrong here, because I would have thought this code would have worked, but I guess not. So for board and bingo boards, okay, let's just take a step back for a minute. So for board and bingo boards, because apparently that did not work. And then I should have kept this, I guess. So for board and bingo boards, latest ball. There should not have been a winning board. Winning board. Oh, I see what I did here. I see. Sometimes it's just really stupid things like this that I just did not do appropriately. Okay, so let's try this again. All right. I should have put that -5 there. That was what my issue was. Okay. All right, so all right, so bingo boards. All right, is there a winning board? There should be no winning board. Winning board. There is no winning board. Okay, perfect. All right, so let's go ahead and take out the sample balls. All right, let's see what happens when I put in all the balls again. Bingo balls. All right, so bingo balls. Boom. All right, so winning board. Dang it, we're getting closer, but still not correct. And let's check all the bingo boards again. Bingo boards. All right, so we have a lot in here, but okay, so this one, I mean, it looks like they're starting to get marked off appropriately. There must be something wrong to where it's not checking a bingo appropriately. For I in range, if equals -5. And what was the last number? So let's check bingo balls. And so if you want to check the last number, it's the -1. All right, so the last ball is 81. So it's going all the way through and it's not breaking. So that's the issue. It's not. So for board and bingo boards, like how do I get, like, does it just not just keep going? Like, I'm doing something wrong with the breaks, it looks like. All right, so it's not continue, is it? For board and bingo boards. All right, so for I and all right. So, okay. I mean, we're getting so close. I know we are. But we want to break the loop if there is a bingo. Okay, so, well, let's try this again. All right. All right. So again, restart and clear all output. All right. Latest ball, last board. Okay. Well, we want a winning board. No, last board, winning board. The winning board was just a bunch of -1s again. Okay, but it's not breaking when I need it to break. Well, I got an idea. So let's see if it's breaking somewhere. We have a winner. Vertical winner. Horizontal winner. Print. Well, If board I dot sum latest ball equals the bingo ball, board winning board is a board, and then we want to break out. So we break out of that loop, but we don't break out of the bingo ball loop. That's the issue. Okay, so how do I break out? How do I break out of the whole thing? Nested for loop breaks. Nested for loop breaks Python. All right, so I have 5 ways how to break out of a nested for loop. Oh, I know how to break out of it pretty easily. If winning board break. Like, yeah. Okay, so that maybe that's the whole thing, is it just wasn't breaking appropriately. Winning board is not defined. Okay, yeah, so the winning board is not defined. 5 ways how to break out of this thing. All right, so okay. If winner equals. Okay, so winner equals true. So basically what I'm doing here instead is, if we have a winner, then we're telling the top level to break out of here. Okay. Kernel, restart and clear all output. Horizontal winner, horizontal winner, horizontal winner. Uh-oh. When do we get to this point? See, like, if we saw that once, that we should be done. Like, we shouldn't have to keep going. Oh, I wonder if we need to do that again here. If all right, do we need to do that here to break out of this loop as well? Maybe. Still got these horizontal winners here. Okay, and then this is getting really kludgy, and I'm kind of getting a little bit desperate here. If winner break. Okay, so let's try this again. All right. Didn't work. All right, did not work. Okay, so why isn't it not breaking out of this loop? That's the whole big question here, isn't it? Because it's not actually breaking, is what we're finding. 5 ways to break. The break only helps us to get out of the innermost loop. Unfortunately, there is no built-in support operation for this. The break PHP. All right, so add a flag variable. So for I in range 5, if, well, let me just check to make sure. Winner. All right, so winner equals true. If winner print yes. Okay, so that is true. All right, so we're setting winner to equal false. If winner. Oh, that's because we're falsifying it each time. Okay, so we need to. I need to pull this out of here. All right. Okay, that was my bad. Instantiating a variable that indicates if there is a winner to break out of nested for loops. And I'm sure somebody in here is probably banging their head against the wall thinking like I'm doing this like the stupidest way possible. Maybe. Maybe you're right. I like to do these things as separate cells. Just cause. Alright, so winner equals false. So that's what was going on here. Is it wasn't breaking. Alright, breaking the loop if winner is found. Alright, so basically we need to copy this everywhere. Breaking the loop if winner is found. Breaking the loop if winner is found. Boom. Okay, and then I need to put those winners back, I guess. So winner equals true. I'm very now like when we're done with this first challenge, I do want to look like I am gonna like look at somebody else's code to see like if they did it a lot cleaner than I did, because this is not clean. Just being totally honest. All right, winner equals true. True. All right, so we can delete these. Latest ball, winning board. Delete those. Latest ball. All right, so now cancel. So kernel, restart and clear all output. All right, now fingers crossed, did this work? Latest ball went. I think we got it. I think we have it. Okay, so now we basically need to add up all these values and take out the negative ones. Okay, so the easiest way to do this is going to just be changing those negative ones back to zero. All right, so changing the marked values of the winning board from -1, not -1 to 0. So for x comma y in, and then np dot index winning board dot shape. And then what was the code here? So if -1 winning board equals -1, then winning board xy is now going to be equal to 0. 0. All right, so let's check out the winning board again. All right, so perfect. All right, so winning board dot sum. Can I do a whole sum? All right, so sum. All right, this should be the end here. All right, so let's go ahead. Oh man, no, I'm not going to delete anything. Let's see if we get the actual value first, because I think what was the final thing? We had to just multiply these guys together. All right, so this is the wrong day. Wrong day. Let's go back to day 4. All right, so we basically, to get the final store, you need to multiply the number that was just called by so the sum in this case of all the unmarked numbers. Perfect. Okay, so let's come back to here. So the what is it? To guarantee is what we the final score is printing out the final score. All right, print f. The final score is, and so we need to do winning board dot sum times latest ball. That should, okay, this should be our answer. And if this is, then we're done. And I'm going to call it a day. And I'm actually not going to review that other person's thing. Anybody else? I mean, I probably will on the side, but. Woo! I'm thrilled. Hot dog. All right. All right. So that was. Let's go ahead and clear out all these other cells now because we don't need them anymore. Clean this all up. We're. Wow. Wow, that was something else. Let's go ahead and rerun all that code just to make it all pretty one more time. Oh man, I'm thrilled. Isn't that fun? I thought this was fun. It only took me like 2 hours. And the sad part is so there's two challenges to each of these days. I still got to do part two, and I know the good news is part two usually builds off of part one. And so yeah, this is the final code in the end. Let me go ahead and I'll push all this up. Oh man, that feels good to have that totally done. I learned a lot about matrices. So again, this is another reason I like doing this challenge aside from it just being a fun thing. Wow. Wow, wow, wow. I can't believe we finally got that done. I feel like I feel like this has to be the kludgiest code in the world, but it worked. Now I'm gonna check because there's like a subreddit that will because I don't want to cheat because they're usually the people. I'm not gonna check right now because usually whenever like somebody posts their answers, they post part one and part two, and I don't want to see part twos yet. But wow, so that is the final answer. Please, please, if you are doing this challenge and you go and fill out this thing, just don't go fill out even though this is the answer, do it for yourself. Or if you did it together, then that's fine. If you did it with me, that's fine. But let me go ahead and push all this code up to GitHub. So I term. All right, so repos ls. Did I save this? Let's do Control S. There we go. All right, so cd advent of code 2021 ls git status. All right, so cd day 4 git status. All right, git status git add all git commit completing part 1 of day 4 git push origin main. Boom, 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 boom. All right, so let me check. Did that push up to GitHub just fine? All right, so github.com/dk only. Boom, 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 boom. All right, and we're just about done here, people. I appreciate if anybody stayed online. I don't know if anybody's here or not. Okay, so there's part 1 of day 4, 23 seconds ago. All right, there we go. Part 1 of day 4 in the books. That's my code. I learned it. All right, that took a long freaking time. I honestly thought we were gonna get maybe through like 2 or 3 challenges because I did the first 3 in like an hour and a half, and so the fact that it took me almost 2 hours just for part 1 of day 4, I'm not embarrassed by it at all. Because that was a sufficiently hard challenge, and I learned a lot of new things along the way. So yeah, I hope you all had fun with this. So obviously it's the 10th and I am still way behind. So I've got a lot more challenges to do. We got the weekend here and then I'm working all of next week. And then I'm taking my family up to Chicago to look at Christmas lights that weekend. So we won't be doing a stream next Friday because I'll be in Chicago. But then the following week, the week of Christmas, I'm taking off. So this is actually, just by my own personal choice, this is actually the first time I've taken a full week off since 2015. Now, excluding my daughters. I did take a week off whenever my daughters were born. However, that wasn't that was fun, obviously. I love my daughters. But I didn't take that off for like a vacation or anything. I had not taken a week off since 2015. Again, that's not because State Farm's been pressuring me to not do that. It's just... when I grow up, I didn't really go on vacations, so I'm not really used to going on vacations. I prefer to take random days off here or there, but I just decided, you know what, I'm gonna take a full week off. So maybe that full week of Christmas off. Now I am going to St. Louis again because I'm taking my family to St. Louis. But maybe during the days, maybe I'll do more live streams like this, and we'll do more challenges together. But wow, that was a doozy. Well, I don't know. I'm gonna probably Google things after the stream ends, but I'm gonna end the stream here. All right. Thank you all for sticking around. I hope you all had fun. I hope you all learned something. I definitely learned something today. And let's go ahead and call it a day here. Hope you all enjoy your weekend and your holidays. See you later. Go ahead and call it a day here. Hope you all enjoy your weekend and your